Okay, hello everyone. Welcome to the seventh event of Encode Tezos series. Today, we'll talk about front-end development for decentralized apps on Tezos. This event is part of a broader Tezos series to give you the tools needed to get building on Tezos. For those who want to get involved in the Tezos ecosystem, we've already had a wide range of events for both technical and non-technical folks. They can check on our YouTube channel. So Tristan and the Tezos team will be giving the presentation for us today. Your questions are very welcome. Drop them in the chat, and we will get back to them over the course of the talk. The presentation will be recorded and will go up tomorrow on our YouTube channel around lunchtime. So you will be able to look back and share it with your friends if you like. We'll also drop various links about Tezos program, which besides the educational events will include a hackathon and an accelerator. And all of these programs are dedicated to learning and building on Tezos. So let's kick this off, and don't forget to drop any questions in the chat. So Tristan and Tezos team, thank you very much, and the floor is over to you.
Thank you very much. Good. My name is Tristan. I'm working at Tezos Connect along with Anita and Dani that you already know. That's been presenting the presentation about UX and smart contracts. And today, the focus will be on front-end developments for the apps, and especially in Tezos, obviously. So just like a quick introduction on like what is the outline of the presentation and what are the different points that we're going to go through. So first of all, I'm going to give like a really short introduction on what is exactly a dApp. And then after this, I'm going to give you like just like some tools that you're going to need like to build like your first decentralized application to actually mint token NFT more precisely on Tezos. And then after that, I'm going to show you how to mint it with like small snippets of code. And then when my part is done, I'm going to hand over to Anita for the blockchain and UI. So first of all, small introduction on what's dApp. So I guess that most of you already know that dApp stands for decentralized application. But what's the decentralized application? So you shouldn't be afraid about the word decentralization. On the front end side, it's mostly like any other normal app. The only bits that is here that we're going to have to manage compared to the normal application, it's just going to be like the integration and communication with like wallets, and as well like the communication with the smart contracts. But the app is as well like just compared to what like a normal app is, it's just running on top of a decentralized system like blockchain, like Tezos 10. So basically like the source of truth is fully decentralized, running on different servers and managed by a central entity. So what is actually like the decentralized application solving? So as I was talking about before, decentralization is just like peer-to-peer means like no central system. So actually like there is no one authority that is actually managing like everything below the application. So pretty useful if you just want to have like connection and sell, for example, like an NFT between like to your friends, and you don't need like to go through like a central system. Though it doesn't like always rely on a central system, meaning that like, for example, your front-end application can be hosted like on a central server. So like this question of decentralization is always like a big question, because when we talk about like IPFS hosting, like it's always like at some point, like we always have like to make decisions to either go full decentralized, which is like rarely the case, or sometimes like just like, for instance, like just host our front end on like a specific server instead of like just like putting like all the static files on IPFS. This way, for example, we can have like new versions of the app, and it's like a lot easier for us like just to to update the app. yeah, IPFS, I don't know if most of you know, but stands for Interplanetary File System. So it's just like a fully decentralized way of storing data on different servers. The app as well like solve the problem of transparency. So most of the time when you're using an application like on the internet, problems that like the source code is not open source, and because it's not open source, you have no way to actually verify what is the code doing exactly. And that's as well like something that we here with pushing forward. Everything that we're doing is open source. Anyone can check it, and therefore check if there's any bugs or if we're trying to do any malicious actions against you.
Yeah, by the way, just to jump in for a second here.
Yeah.
So if you do use, and you probably will use centralized servers and hosting your decentralized application, especially since, we've talked about indexers, and Tristan will do a little mention of them later. So you will be using a centralized server, but it's really good practice to allow people, especially people who might be doing like high risk operations, for example, in DeFi or with NFTs, like they're minting really expensive NFTs, to host the centralized components of the app themselves. And since the blockchain is the single source of truth behind it, it will like be possible to do it this way. And this empowers their users to take their own like operations into their own hands. And of course, like this also becomes part of the user experience, like how easy it is to deploy your own version of a decentralized application. Do you need to like be an expert programmer, or maybe can you just say Docker, Docker up, and it's running now on your server? So it's also like another thing to think about and consider when you're developing and deploying.
Agreed. So going back to the slides, so this was like full for transparency, open source, and who's basically earning what. And then like just following on this, like what is as well nice, really nice, like for like decentralized applications, just basically checking like the history. So it's the ability for anyone to check and verify like all the transactions that happens like with the app. So like because of the blockchain, like we can just basically like follow like all the stream of data and who transferred what, when, and where. And so this way, really be sure of what we're getting and that no one manipulated the data. So how are they composed? Because like obviously it's like a normal app, as I said before, and what's the added, like what is exactly the added value for that? So in order to run like a decentralized application, first of all, you need to deploy smart contract. This is must to have. So smart contracts, Dani already talked about it, like in previous presentation, creating a bunch of things for it about it. But this is actually what we're gonna have to interact with our, like here we're gonna talk about React, because like in our company we deploy, we code everything on React. And of course, so there is like all the off-chain system that is built like around the decentralized application. So there is first of all like this user interface, which is React again. It can be as well like a desktop application, could be like a CLI that you built, any software that is actually off-chain. And Dani was talking earlier about like Indexer, and I just wanted to bring this on the table like for the presentation of decentralized application, because we're like here like at EasyConnect like using it a lot. We're using it to Capasa. I forgot to put the link. I will put the link later. So Indexer is just basically like a controller of the blockchain. So it's just a way, it's just a software that is like crawling the chain and indexing smart contracts in order to basically like put the data that are in the smart contracts in the database, which is going to make it a lot easier for us to actually read what's on chain. So decentralized front end will more connect like to the smart contracts and send action to it. So it's going to be like more transactions that we're going to send to it, but we're not going to read directly from it. We're going to read everything like, or most things like from the database that is fed by like the indexer.
Yeah, if anyone's like familiar in like enterprise software architecture, there's this thing called CQRS, or Common Query Responsibility Segregation. And this is like an example of that. So we are like using a separate route for write operations and for read operations, and both are of course optimized for the needs of those. So writes go directly onto the blockchain because they of course need to, and reads can go through the indexer, where we have like much higher throughput and better querying capabilities, etc.
Yep. So yeah, that's the bits on what you'll need to actually for like what you will need to build like your first dApp to mint an NFT. So first of all, you need to create a Tezos wallet. So why do you need a wallet? Then you need a wallet to communicate with the chain, because like all the transactions that you're going to send to the chain needs to be signed, and they need to be signed by your wallets. So they need to be signed actually by the private key, and the wallet is holding the private key for you. And wallets is a really good tool when it comes to securely store the private key. I mean, there's different kind of wallets, and then we can talk about the security and having your private key held like on a data center or on your browser or on a key like Ledger, for example, as a hardware wallets. And as well, like these wallets help you have like a easy account management, meaning that you can have like different Tezos address like within one wallet. For example, Tezos like just allow Temple just allow you to import like many accounts into their wallets, and it's very useful. Even for developments, when you want to have like different interaction between users, I'm really using Temple a lot, like just to basically create different accounts and just like send transaction between like all these accounts and just basically see what's happening. So here I just put like some links of like the favorite wallets that I have. So Temple Wallets is the browser wallet. It's very, I mean, it's my favorite one from the browser. Then there is Kukai. Kukai is basically holding your keys like on the cloud, and it's very, very useful to.
Actually, that's not true, and that's a good thing about Kukai, that it does not hold your keys in the cloud. Kukai generates a key pair deterministically from like your login data, and of course that means that the key is only ever present on your computer, on your browser. Well, since it's in your browser, that's of course going to be less secure than, for example, having a hardware wallet. But it's in a way, it's more like decentralized and more autonomous than, for example, having a custodial solution where someone else has the keys.
Thank you for the correction. Very Kukai is one of my favorite wallets for the dApp, though. The reason why is because like it allow users to connect to a decentralized app using their Google accounts, Reddit accounts, and all these providers. So there is as well like a version of Kukai which is called Kukai Embeds. We're not going to cover in this presentation, but it is pretty nice. Like when it comes to building decentralized application, because like it really is like the connection and the onboarding of new users to your app, because we know that creating a wallet for user for your decentralized application is going to be like a big problem, because they need to understand what's a wallet, how it works. Then once they have a wallet, they need to bring money into the wallets, actually like crypto, and then like all this interaction maybe sometimes like can be like a little bit stressful for users. So Kukai is kind of bringing like a new solution that is like pretty useful for that. And Ledger, obviously hardware wallets, this is most secure.
Yeah,
as far as I know.
If you want to like handle more than like maybe 100 euros worth of crypto, then I think it's just far too risky not to use a hardware wallet.
Yeah. Then yeah, when it comes to installing like now like the important packages for your front end. So there is like two main packages that I'm using when it comes to building like front end application. It's the Beacon SDK. which is basically like the implementation of the TZ10 Tezos standard. So I don't know if you already had the link, like for the tzip repo on GitLab. There is like all the standards that are like stored there. It's pretty nice, like to go through all of them. Like if you really want to understand like what they're doing, and this is just basically the wallet integration, some interaction standard. So just allow your application to communicate directly with your wallet. So we're going to see like a small snippet of code that is an example to actually like request a permission to your wallets, browser wallets, in this case, like in order for you to unlock this wallet and just give the permission to the app to actually interact with your wallets. So like small comments here, just like a small comment for you. It's like just here on add air gap beacon SDK. Then after that, we have Taquito. So beacon wallets, Taquito blockchain. So Taquito just TypeScript library. It's developed by Encode Labs. And this one really allow like your React application to communicate with the contracts. I mean, not only communicate, can as well like originate a contract, compile a contract. I created as well like a small CLI that I'm using a lot instead of Truffle, like just to compile my contracts and deploy them like on testnet and mainnet, and obviously some transactions. So this is as well like yarn add Taquito / Taquito, pretty basic. So now we're just going to go through different steps on how to mint an NFT in Tezos using React. So just small snippet of code just for you to understand like what are like the big lines on it and what are the different steps that you need to achieve in order to mint this NFT. So first of all, you actually need to connect your wallet and grant the permission to your wallet. Without this, the only thing that you're going to be able to use to do with Taquito is just like read data from the chain, because you can as well like read data without needing like to sign like your wallets. Then second of all, they're going to be like all the upload of the APFS metadata of your NFT. Like here it's in specific order because we're going to upload like different things to APFS, and they need to be linked together in order to be then pushed to the smart contract. Then after, we're going to quickly see how sending a transaction chain using Taquito just to create a token. And there is like just a small point on waiting for confirmation, because there is, Dani can talk a little bit more about this later. There's like a big difference into like the different errors that you're going to get back from a contract. And then finally minting the token and checking it in your wallet. So this is like a small snippet of code to actually connect your wallet and grant the permission. So here, as you can see, I'm importing a bunch of things from the air-gapped beacon SDK, which is the app client, network type, which is just basically giving me like different networks that from Tezos. So, and then just like function response, error response, which is like just like the type that we're expecting. So, I mean, I said earlier that like Taquito was like a TypeScript library. This is why we're writing as well, like in TypeScript here. So here it's pretty straightforward. You can see it's like, I'm just creating an app client. The only thing that you need to give like this, the app client class is just like a name for your app and a preferred network. Obviously, you don't necessarily want to like to directly push your app on mainnet, and you want to maybe test it like on the testnet and everything. So then after, just request the permission, and then classic asynchronous code using the TypeScript, getting the response. So here I'm just logging everything, but here with this address, you might want to do other things. As we said earlier, like indexes or good things like are really good, like in order to read the data from the chain, but in order like to read data from a database, then we're going to need as well like to have an API that sits on top of it. And if you want to do like any like user management on top of this, then we might need to have an authentication system. And if this is the case, then we might want to use this address that we're getting back from the permission to, after that, sign a payload using our private key that is in our wallet in order to generate, for example, a password. So that's the very, very first basic step. Then after this, we have like all the steps that are here, like to upload So IPF has a token metadata, and it needs to be done like in a specific order, in a sense that. So let's take the example of, for example, maybe you guys like already like went into object.com, which is like a marketplace like on Tezos, like to actually buy NFTs. You can see that most of the NFTs are either images, GIFs, videos. So what we need to do first of all is like just upload this image to APFS in order to get like a hash back. Once we have like this hash back, then we're going to be able like to put this hash of the actual image, which is like the artifact, and put this artifact into like a JSON object that will define what are the different metadata of our token, because a token is not only an image, it's as well name, description. It can be like formats, like we can put like many things like into the different metadata of the token. Once we upload the image, got it back, put it in JSON, then we're going to take this JSON and we're going to upload it back into APFS. So there is like 1, 2, we can do it like many times because like as well like in the TZIP12 you can see, but there's artifact, display URI, and as well thumbnail, right? Sorry, forgot about it. And so these are like different images with different sizes, and we need to all upload them. They all have a different hash. And so when we have like the response from this IPFS upload with the JSON, then this is going to be like the token metadata that we're going to have like to upload on the smart contract. So here just like showed you like a small as well like snippet of code on how I'm uploading, for example, to IPFS. So it's pretty straightforward. This is like just a function that is like responsible to upload everything. So I'm just passing a file and then a bunch of information that's going to be used to upload the JSON. So here I'm just creating form data because we need to send everything in form data. And here I'm using here, as you can see, React app Pinata GWT. I didn't put as well like the URL, I mean the link for it, but Pinata is a service that is actually used in order to pin data on IPFS. And maybe then you can talk a little bit more about this because we were talking about centralization and decentralization. And Pinata is...
Yeah, so IPFS is decentralized and it's free. However, it is not a permanent store. So data is retained in IPFS nodes based on how frequently it is queried or like requested. And so if data is not extremely popular and there's like like too much data, there's always too much data in IPFS. So there's like this this kind of like competition between pieces of data of which one gets requested more. And if your data falls like behind in that competition, then it will be ejected by IPFS nodes. And so it will be gone from the network after a while. And pinning means running a node, an IPFS node, where you tell the node to never evict certain pieces of data. And then if somewhere in the network that data gets requested, then the network will, of course, find a route to your server that's where that data can be found. And of course, the most decentralized way of this would be for everyone to run their own IPFS nodes and tell it like what pieces of data are important to them. So for example, if you own an NFT, you could run an IPFS node and tell it to pin the metadata and artifact of that NFT because you own it. And if that data is lost, then your NFT will lose most of its value. Now, Pinata makes this pinning a lot easier in that it is like a cloud service that you can pay and then tell it to pin certain data on IPFS. Of course, this means that in a way decentralized, both centralized in the way that it's like one company, and centralized in the way that there's like one person or entity paying for the pinning of these assets. And of course, this is something that, as I think we might have mentioned that in the last the UX presentation, that it's something that you should probably think about on how to communicate to your users and how to make it easy for them to work around or work with this like centralization in the system, and of course do whatever needs to be done for them to be like autonomous and independent of this.
So basically just be ready to pay in data for your users. So yeah, going back to this one, this simple function. So just the form data, as you can see here, I'm just uploading only the NFT file. And then after once I uploaded this and I'm getting the response from it, then I'm just basically like giving this hash back to this upload metadata, meta to APFS, which is this function. Looks very similar. The only difference is that like I'm uploading like a different kind of data, which is here like a JSON object. So here, for instance, I just like put like the different metadata that we can put like into a JSON object on IPFS. So there is always a symbol, description, and name. Artifact URI is like the real data that you have. So like the largest one, thumbnail is like 350 by 350 px. It's just here like to basically like display your NFTs like in the right way in your wallets and don't have like props image or like just like basically deformations. And display URI is the one that is used basically that you're going to use like in your decentralized application. So it's a little bit smaller than the artifact, bigger than the thumbnail. So this way you just have like the perfect size of the image to be displayed like on a computer. Then there is decimals. Here, small mistake, sorry. Decimal should be either not token ID at all. Then we have like the different tags that you can put to your image, the attributes, like in case you want to do like, for example, like auto-generated like NFTs, then the formats of like all the different files that you pinning, and then the creators as well of this NFT. And this is, for example, I just went like quickly on object before the presentation and took a screenshot of what we're getting when we're sending a GET request on an IPFS hash. I mean, like to a gateway for the authors. Maybe you guys know what are the authors, just a collection that is on object.com. And this is a little bit like how it's going to be. As you can see that there's like a little bit more fields, but these are just fields that are required and they will always be there. So now that we've seen like everything that is related to uploading to IPFS, so now we have the metadata of our token, and then we have like all the necessary information to actually interact with the contract. So the thing is that we're going to have to send a transaction in order to create our tokens. So here, for example, in this example, we're using the FAT contract that has been built by Tezos and that we're using here at Tezos Connect to create NFTs. And there's like two entry points that we need to call in order to create an NFT. First is like the creation of the NFT, which is creating the metadata that is related to the NFT, and the minting would be to actually assign this token to several addresses with like a specific amount. Here I didn't forget to put the link. So here, this is like the small snippet of code that I'm just using like to actually interact with the contract. So we can just go through it. So here I'm really using Taquito, like I told you before. So Tezos Toolkit is a class from Taquito. So the only thing that is accepted is like an RPC URL, which is like basically like a node reading like the blockchain. So here I'm just like, so getting this toolkit, assigning the wallets. Forgot to put the small wallet, but this is like just this is like something that we're getting from Beacon. Then after using this toolkit, then what I can do is like just basically fetch the contract that is a specific address. I'm sure Dani already talked about it, but all contract addresses like in Tezos start with KT. So here is KT1, and then like your deploy contract. And after this, what we're gonna do is create the token information. So this is actually the parameter that we're going to pass to the function of the entry point to the contracts. So here we just create like a Michelson map, And here, as you can see here is like there's this empty strings as a key, and then char to byte IPFS metadata URI. So you might wonder why we're doing this. So the IPFS metadata URI is what we're getting from IPFS earlier. We always need to transform this string into bytes in order to send it to a contract. And this is basically following TZIP 16. So we don't have to actually pass a key like to a token metadata, just the IPFS URI is enough. So this is just following the different standards. Here, this is not the best practice, but I just like put it for the sake of simplicity. So here I just fetch like the contract storage, and I'm just taking the next token ID. Like Dani can talk more about this, but token ID needs to be deterministic. So meaning that like they need to be absolutely unique, and you don't want as well like people like sending transactions at the same time on chain on your contract with the same token ID. Otherwise, they will fail. So this is not best practice, but for the sake of simplicity and for you for testing, it's actually working specifically with this contract where only an administrator can create tokens. So there's only one person that is able to actually send transaction to the contract. And then here, as you can see, I'm just like basically creating the transaction. So everything is wrapped up into an array. So I just put one single transaction into an array. And the idea was like just to show you that here we can pass like a bunch of transaction at the same time. So we can send like a batch of transaction to the chain instead of like requesting like many operations. So let's say you want to create a token, mint a token at the same time, then you could do it. But if you want to create token, mint token, and list a token in your listing contract, then you could do it as well, like just sending like all these different transactions at the same time. Then once we just send the transaction, then we just basically send the batch of transaction and wait for the confirmation. So waiting for the confirmation means that we might have errors. I know, Dani, you wrote Peppermint, and you have like good understanding of errors here because there's different kind of errors.
It is like all I can say because like we don't have a lot of time. All I can say is that unfortunately the error management in the current version of Taquito leaves to be certain things to be desired. So when you're doing your error management in a live production piece of software, you kind of need to read the whole like documentation about Taquito errors and Tezos errors. So like all the error codes that you can get back from a Tezos node, and then do some testing and see like how these errors actually manifest, because one thing that we had was an error from the node that was like specifically a Tezos error about like what we're trying to do on chain, manifested as a network error in Taquito. So it had like it was tagged inside the network error object, and then inside it had like the HTTP response, and in the HTTP response we had like the Tezos error message. So the Taquito error handling has like this really complicated like multi-chain thing of like, okay, so is this like this kind of error? If it's this kind of error, can we unpack it into a different kind of error? So it's like, you know, not a very straightforward, but we had to do it because the way we got back these errors from the node and from Taquito were relatively chaotic. Yeah, so that's a thing that, you know, and I think it changes because Taquito is under heavy development, so they are fixing things, they're improving things. So whenever you're doing your software, of course, I'm not saying that this needs to be done for like a proof of concept or a hackathon submission, but if you're building something for like proper live use, then do some testing, some serious testing, see some errors and work on it. Generally with the blockchain, you will get two different kinds of errors. You will get like retriable errors and persistent errors. And of course, persistent errors means that the error is like dependent on like what you're trying to do. Yeah, like you're trying to run a script or a smart contract code that is, you know, that fails. You're trying to do something on a smart contract that does not exist or something like that. And of course, there are errors which are intermittent that can be retried. These can be like network errors. The node is not available. The node's mempool is full. For example, this used to be a really big like issue with the Tezos, the Octets node implementation up until recently. I don't know if it's still there. That it returned this really hard to understand out of gas error, even though it had nothing to do with your operation. It was just that the node itself was overloaded and you had to retry in a while. So there's also like a case when, for example, you don't have enough DAS to execute something. Of course, in a way that's persistent. In a way, it's intermittent because it will be doable once you have enough DAS, for example. So this is all like things that you need to think about how to handle, especially with the UI, like how to present it to the user. So it's really error handling is probably one of the big chunks of development time in creating like a fully production ready app.
So far we're just missing one more step, like for the creation of the token using like this contract, and after we're going to be done for that. So it's the actual minting state. So now we created the token, we have like the IPFS data, like all the metadata of the token on chain, but the token is not assigned to anyone, so perfectly useless. So now we're just going to send like a transaction to mint entry point, and the only thing that we're going to have like to pass is like token ID to address. By to address, I mean like someone that we're going to send it to, and an amount of NFTs that we want to do. And then the only thing that we have to check after this is check if it's present.
Yeah. Oh, by the way, yeah. So amount of NFTs, that's funny because of course NFTs are non-fungible, so they wouldn't have an amount. We're using the TQ Tezos multi-asset contract, which allows for both NFTs and semi-fungible tokens, which means like you can't have like multiple of like the same token. And that's why we have to specify amount. With NFTs, it's like always one, but if it's like semi-fungible, like an addition of 100 or 1000, then of course I could say that, oh, I'm sending you like 10 additions or 10 copies of this like limited edition collectible.
And just going back on this quickly, just to show you guys, there is like an is Boolean amount here on the IPFS metadata that you can specify for that. So if it's true, it means that there is only one. If it's false, then means that there is multiples. So in this case, for example, this Otes is like literally an NFT. There's only one of it. And if it's false, then you just have an amount, and it's just like all these collections that can be used, for example, like semi-fungible tokens, like in order to access to different drops and everything.
Think of it like Pokemon cards, like there are like maybe there's like a limited amount release of a certain like Pikachu card, and then there are like 100 of those, and they're all the same cards. So that's like a semi-fungible.
Exactly. And finally, the small function that, I mean, if you check it, it looks like almost the same as the previous one, the create token. The only difference is like here, the mint token. Just for you to understand here, I just like put like all the parameters as constants, but you just have to pass like the stereo address, the token ID, and the amount, and send the transactions. And here, for example, is like just representation of the token in my wallet of a token. So if everything is done correctly, then you should see this popping up like in minutes, a couple of minutes, like into your wallets. And now it's going to be Anita that's going to talk a little bit more about the UI side, front end application.
Yes, I'm back.
back.
I'm back, yeah. After everyone asked for examples last week, and Dani and I were like, we're not sure, like, what are the good examples? We thought we would properly put together some examples as it relates to the front-end interface development. And yeah, we decided to make this slide have hearts in it and broken hearts because it's a complicated relationship with blockchain and UI so far, but we're all going to make it better. Okay, so just going to the concrete things that you'll definitely need to have as you build your interface and just thinking about decisions and best practices. So of course, obviously, you're going to have a wallet connection flow. And for your wallet connection modal, here on the left, we have the beacon modal, which is just out of the box. It can be completely sufficient if you are in a time crunch and you're in a hackathon, for example, it's completely fine, I think. And also if you have like pro users that you expect in your application that know what to do here, understand that, oh, I clicked a button and all of a sudden there's a totally different styled and totally different branded modal coming up. So yeah, I think that this native modal is only best in cases where people already expect it. On the right-hand side, we have kind of like on the opposite side of the spectrum, an example of a modal that kind of is best for onboarding users. So it's natively designed so it looks like it's part of the app or it is part of the application. Also here, the language is a bit mixed, but in the header and in the primary button, it says sign in. So like last week, we talked a bit about kind of UX copywriting being an important aspect of the blockchain, and using familiar language or concepts can be useful to introducing people to this space. And then beneath sign-in, we have a flow explanation. So as you know, once you're connecting the wallet, it requires some outside of application interaction. And the wallet isn't going to necessarily tell the user to make sure to come back and get back to what they were doing. So this kind of helps explain to users what's going to happen, but tries to keep it brief and personal, I would say. And then here we have two buttons, one's styled primary, one secondary. So the primary is kind of like what you're emphasizing to the user. You can kind of like suggest like which direction, like nudge them into a specific direction. So as Tristan mentioned before, like if you use Kukai, it's really easy to just use any, I don't know, Gmail, Twitter, Reddit, whatever, to create an account. As Dani mentioned before, it's not always the best choice for users. So there can be more education around like, okay, like, do you mean this to like make your artistic identity on the blockchain? In which case, maybe just use Kukai to explore for now and invest in a ledger. But at this moment, just funneling people toward the easiest thing to get them moving into your application is nice for first users. Then at the bottom, we have a link to learn more about wallets. So this, again, like what we talked about last week, how you always have this kind of like meta flow to keep in mind about educating users and making sure that there's always an information funnel to what do I need to know now? What is the background information that I can learn? And also just go all the way down to wherever that code is living. So yeah, just having a little link there to supporting resources. Okay, once people are signed in, I mentioned this in best practices last week, but basically just always giving feedback about the wallet address that is actually connected and the balance is really useful. Based on user testing that we did, I think this was an application we built, and initially we just had an icon, like replace the button with this circle image. which really is not familiar to the user actually, until they do it for the first time. So, but what is familiar to them is their wallet address and their balance. And so this just provides additional feedback. Like when we user tested, people understood more like what exactly was happening when they had this information always visible in the navigation. It's also good to have just because obviously if they're going to do transactions in the blockchain, they're going to have sufficient balance for whatever they're doing. And to always have the balance as a reference point in the navigation is good because it prevents the error of like not having sufficient funds. And
or being on the wrong address or the wrong
Yeah.
wallet. Like,
Yeah.
for example, you have a hardware wallet and one of your addresses on it has your life savings and the other has, you know, like $500 for like playing around with NFTs. You definitely probably don't want to do these things with the address that has your life savings. So.
exactly. And yeah, and then here on the right, we have a modal that if you can expand, if you click on the little chip, then it expands and then has a sign out button and the same information. One small thing that I didn't make a note about was just the simplicity of copying the address. So we have like the address abbreviated because they're obviously very long, but copyable just by a click. And then also the sign out button is just an example of how if you say sign in, then you should also say sign out. If you say connect wallet, you should say disconnect, and just use kind of mirrored language and also mirrored UI. So both of these, for example, use the same button style. Okay, so moving to contract interactions, I just wanted to show a couple examples. Last week I talked about Versum and thinking that was an interesting project with pretty good UI so far. So the first thing on the top left is just wanting to buy an NFT so you can collect or make an offer. There's two options. There's nothing really to say here except for that, you know, like a contract interaction can look like any other action on the application, and it's also fine. Like we talked about friction last time, but it's not always necessary. Like it's completely fine here. Then on the make an offer, so if you click make an offer, you get the modal, which I put underneath. I put it here just as a bad example, actually, because they didn't use units here. And this is, I mean, they label the field as price, but it's super important if you're using Tez or, I don't know, like a different currency.
Or,
exactly.
Or US dollars, or like, it could be anything.
Exactly. So this is a pretty bad error, but otherwise, Versum's like, yeah, doing well. But I just wanted to put it there to emphasize that it's super important, especially in kind of like higher stakes and losing money interactions. On the right, I put an example of something that we built earlier. This was a prediction market. And I put this here just to show the connect wallet to buy button as an example of having no dead ends. So this is the view. Basically, it's like someone can bet on a specific outcome of an event in the future. And this is the view if they're not signed in. One option would be to just disable the button and require that they log in the navigation. But it's better to have the button enabled and actually link to connecting the wallet so that then they can continue in the flow. So basically, when you're thinking of different options of how to handle different cases of, you know, like the user state or something, just consider like no dead ends. And this is an example of how to do that. Another example of when to connect to the wallet, this is taken from a project we've also built that Tristan has been leading about, it's an NFT marketplace also. But so this is, you can add an NFT to your cart and go through step 2 of 3 of the payment process and not have to connect your wallet yet. And it's just until the payment method that you connect your wallet. So the kind of philosophy here is as kind of traditional Web 2 purchase method as possible and kind of like the smooth experience of that. And so this is also another option. I think it's always a good idea, or it can be a good idea to let users get as far as possible without having to do something like connecting a wallet or forcing a specific action. So when you click this, then you have this, again, guided modal that pops up and uses many of the same things that we talked about in the first slide on best practices and kind of guiding people with wallet connection. Yeah, and then just a note on errors. So this is from something else that we built where we had a send NFT function. And I just wanted to show, like, on the front end, on the design and front end side, kind of what you can do to prevent errors, because error prevention is a super important process for the user. It's way nicer of an experience to be told specifically what you need to do, and then in case you don't do it, get feedback before you do it, and then only, and not maybe be able to actually submit an action that doesn't work in the end. So for example, here for this send NFT flow, we have destination address, and then we add in the description of the field, we have some direction that it has to be a Tezos-based wallet. Also note that it has to start with TZ in that case, which can help users who aren't familiar with Tezos already. And then we said something to double check the address before you send. I don't know if this is exactly necessary. I mean, you always want people to do that. And in some ways, guidance like that can be helpful in terms of education, but it can also lend its way to the kind of like fear mongering that we discussed last time, and kind of like panic mode, and which is not a good user experience, definitely not joyful. So yeah, I don't know. If I were to make this again, maybe I would delete that, or at least take out the exclamation point just to like calm down the energy. And then here, for example, we have someone put in an address that is not a Tezos address. And so we have front-end validation to check before the user can hit send. Optionally, you can choose to kind of disable the send button if the front-end validation doesn't pass. I have mixed feelings about this. I think for something like a single field, it's fine. But when you get to longer forms and you have multiple fields, it can just get kind of confusing if the user has missed the front-end validation and they get down to the bottom of the form and then it's a disabled button. They can just kind of get like confused and don't know what's going on. Yeah, and then in case there is an error, this is an example from Versum. But basically this was their error message, and I think what I like about this is that it adds some guidance like in the troubleshooting. So it gives it's clear that it's an error, it's also calm, but then it gives guidance on kind of how to troubleshoot. So they give you the full code and just tell you that you can copy it in Discord or GitHub, which I think is nice in case like you don't know what to do with this code. At least it's like, at least you can take it to the community and take it from there.
Yeah, ideally though, I like Versum is a pretty big player, so I would kind of have expected them to at least provide like a user-friendly version of the error, and then maybe give like a drop down that would open up with the actual error message for like getting help or like expert view or details or something like that, because like just jumping it on the user that there was an error. So what does that mean? What happened? Is my money gone? Did something actually, did I break something? Did I do something wrong? Was the node broken? So it's anything can go wrong. And I feel like, of course, like if it's like a simple single person hobby project that, or like a hackathon submission or an MVP, then I would say this is perfect. Like if you're doing your own error management for your like hackathon project, then doing this is amazing. But if we're talking about something like Versum, I would say this is like less than minimum effort. Like I would expect something a lot more than this. because like, if you're not an expert, then this won't tell you anything. And at least you should tell the user, like, okay, so what's going on? What kind of error?
Yes. +1. So if you ever need opinions on errors, Dani is your girl. She knows everything. Okay, and lastly, we have communicating success. So this is a page view of the prediction market I was talking about earlier. I will zoom into more specifics so you can actually see it, but essentially it's if the user bought a yes or no token, essentially, then they have a success message at the top with a banner, and then we have different components that appear and have a loading state. So about the success banner to begin with, I prefer persistent banner messages. I think that like banners that are timed, people can easily miss them. And also maybe they might be reading them slowly and then it goes away already. Also, in general, I prefer that movement doesn't happen on an application unless the user takes a specific action. Just as an accessibility thing, it's best to keep kind of independent movement to a minimum. But on any banner messaging, just to have multiple modes of feedback is important. So having brief text, an icon and color to have multiple ways of giving the user feedback. So for example, if they're using a screen reader, they at least hear that transaction was successful. If they're colorblind, it's okay because they have a check mark icon, etc. And then, yeah, having like a header that kind of gets the point across, and then having like a sentence below that has an explanation of one, the blockchain wait time that they can expect, and also any next steps that they need to or might want to take. And then another way of communicating success as it relates to the asynchronous blockchain stuff is to just use loading states for components. So in this case, we added another row to the top of the table, and because this was pulling from the blockchain directly, I guess we just had this as a loading state for like however long it took. So even though they don't get the information that it for sure went through, I guess they don't see it like in a traditional Web 2 way, at least they get the feedback that something is happening. Also, on the right, we added a current balance section at the top of the page, which is a change from before there was any balance. And so they do see current balance, yes, tokens and value. They see these field labels, which already gives them a sense of, okay, the data specifically might not be there, but they know what data will be there. And so filling in as much detail as possible in terms of labels and kind of supporting data or supporting information, and then using loading states for components that will be there once the data is fully loaded helps kind of make the user feel that things have moved forward as much as possible. So I think that is it. Q&A.
Q&A, let's go. That's complicated. So there's a bunch of links. Okay, is there an explanation somewhere on how KUKA is storing private key, Dani?
I think if you read the KUKA's own like website and their own documentation, they have like some information on that.
Mm-hmm. Then we have, do the libraries work with Ionic and Angular? So far I haven't tried, but
I mean,
it's
they
TypeScript, so-
are independent of React. So
exactly.
so React is just what we generally use for front end, but it's just TypeScript and it has like JavaScript bindings. So yeah.
Then this is a new question.
TypeScript, yeah.
Why is IPFS used for NFT rather than that Torrent or any other product?
Well, it's mostly historical, also because I guess it is relatively well suited for this task. Honestly, I don't have like a really solid answer to this, only that that's how, historical decisions were made. And since everyone started using it, others just got on board. It's network effect.
And how about the fiat conversion below the main price?
Okay.
This, I guess, you're referring to one of the slide that had like the price in Tez, and then maybe you saw Stripe, so you might have thought why there's Tez and fiat. Yep.
No, but also maybe potentially talking about how it's useful to show a fiat version of the price as a part of the front end for a user.
It makes sense.
It might make sense, yeah.
Yeah.
I think we can.
It could also be relatively confusing if like especially for new users who are new to the blockchain. But yeah, I do think it could be like a good thing to do.
I think it's something that if it comes up in your project and you think that it's an open question, is worth like user testing, just like bringing to a couple of people and asking what they make sense of this, like, yeah. And then I think you can get your answer on if it's like useful for them or not in that context.
Okay, if there are no more questions, then I can say thank you very much for the Tezos team for giving this really insightful presentation. And thank you everyone for joining the event. The slides and the video will be up tomorrow. And if you have any questions, we're always available to answer those on Discord. So next week we have another Tezos event, which is called Building a dApp on Tezos, which will be a great opportunity to delve deeper into the dApp development on Tezos. So thank you all for attending the event, and see you in the future programs and events. Thank you.
Thank you.
Bye-bye.
Bye-bye.